All right, today we are solving equations with proportions. Just really quickly, let's remember that when we have proportions, proportions are just ratios. All right, another way to think about them is fractions. Okay, they're also surrounding an equal sign, right? So proportions are ratios that are equivalent, right? Equal, they are equivalent. Okay. So we're going to look at the first problem. In previous classes, you may have learned this in different ways, like different methods. Some teachers call this the baseball method, ball and bat method, butterfly method. In this class, we are just going to solve them by cross multiplying, okay? So I'm going to solve this problem. I'm solving for x here. Because I have two proportions that are equal to each other, I can say, okay, well, 2 times x is going to be equal to 8 times 3. Okay, 2 times x is equal to 8 times 3. So this is really 2x is equal to 24. Well, that's a problem I know how to solve, right? We're just going to divide both sides by 2. And we're going to see that x is equal to 12. Okay, now it's so important, guys, to always check your answers. It's really quick. So we're saying that to check that 2/3 is supposed to be equal to 8 over x. Well, I think x is 12. Hopefully you remember enough about reducing fractions to know that, yeah, that's true. If you did forget, remember you can always just say, okay, well, what's 2 divided by 3? So 2 divided by 3 is that decimal, 0.6 repeating. What's 8 divided by 12? Okay, both sides equal each other, right? So we're getting 0.6 is equal to 0.6. All right, so we know that we are correct. On the right, pause the video right now, and go ahead and try this next problem. Okay, the answer to this problem, you should have found that b is equal to 70. Okay, moving on, example 2. Okay, in example 2, those other methods, like the ball and bat method and stuff, kind of get a little bit complicated here. They start to not work very well because we have now an expression in our denominator. It's not just x, it's x minus 5. Let's approach this problem the way that we normally would. Okay, I'm going to cross multiply. I'm going to do this one first. Okay, 7 times x minus 5. Please notice, I'm multiplying 7 times the entire denominator, which means if I did not have parentheses here, I would be wrong because that would be just 7 times x. If you don't have the parentheses, you're not also multiplying the negative 5. You have to have parentheses, okay? And this is going to be equal to 2 times 14. Okay, so let's clean this up. We've got 7x minus 35 is equal to 28. Okay, I know we can solve this problem. We're going to add 35 to both sides. And I've got 7x is equal to 63. And my last step is going to be to divide. Divide both sides by 7. And I got x is equal to 9. Okay, like always, we got to make sure that we're checking. So I'm going to say check. And we're going to say 2 divided by x, which I think is 9 minus 5, is supposed to be equal to 7 over 14. So really this is 2 over 4 is supposed to be equal to 7 over 14. Well, hopefully you realize that both of those are just 1/2, but let's pretend like we're just using our calculator to check. So we're going to do 2 divided by 4. We're going to get 0.5. Okay, and on the next side we can do 7 divided by 14, and we also get 0.5. So we know that we are correct. Okay, pause the video. Go ahead and try the next example. Okay, in this example, we find that x is equal to 15. Okay, example 3. Now we've got an expression for both denominators. So it gets a little bit more complicated. Let's go ahead and let's get it set up. Remember, guys, it doesn't matter if I do this first or this first. Either way works. Okay, so I'm going to do 5 times x minus 9. 5 times x minus 9. Remember, if this is how you set it up, you're going to get it wrong. What do I need to make sure that I multiply the entire denominator by 5? We need parentheses. Okay, so on the other side too, we're going to do 1 times x plus 2. Here we go. Start solving now. Well, 5 times x is 5x, and 5 times negative 9 is negative 45. And this is equal to 1 times x, which is 1x, or just x. And 1 times 2 is a positive 2. Let's go ahead. We can't simplify. Nothing can be done on the left or the right side to simplify. So we're going to start manipulating both sides of the equation here. I'm going to subtract 1x from the right side so I can cross it off over there. But now I've got to subtract 1x on the left side. So I've got 4x minus 45 is equal to 2. Okay, hopefully we feel really confident from here. I'm going to add 45 to both sides to get rid of it on the left side. And now I've got 4x is equal to 47. Okay, last step is to divide both sides by 4. And I've got x is equal to, let's see what that is. 47 divided by 4. We're getting 11.75. That is a strange answer. We haven't gotten a decimal yet. That answer makes me a little bit uncomfortable. A lot of kids, if they get this answer on a test, they'll bubble 12 because they think, oh, it must be 12, like that's the next closest answer. Guys, no. You did the math. Check your math if you're not sure about it. So let's go ahead and let's do it over here. So we're checking. And we're going to say 5 over x plus 2. So 11.75 plus 2 is supposed to equal 1 over 11.75 minus 9. All right, so in my calculator, I'm going to do 5 divided by my denominator. Make sure you use parentheses, which is 11.75 plus 2. Let's see. Ooh, I get an ugly decimal here. I get 0.36 repeating. All right, you know what? Let's check the next one. We're going to do 1 divided by, let's see, 11.75 minus 9. So 11.75 minus 9. And we get, okay, same ugly decimal. So we know that we're correct. They are matching. Okay? Pause the video. Pause the video, guys. Try it on your own. Go ahead and try the next problem, the UTRI problem. All right. The answer to this UTRI problem ends up being x is equal to negative 2.5. Now we have the back side of this thing. We're getting into some word problems, which is actually really, I think, easier as long as you can set them up. Here we go. On the back side of this paper, we've got a whole bunch of part and total and items and whatever. You know what? I'm not even going to talk about this. Here's how you're going to do these problems. You're going to get them right every time. You're going to be consistent. Okay? You're going to be consistent. So in this problem, it says, a 6-foot tall fence post casts a shadow 2 feet long. At the same time of day, a flagpole casts a shadow 21 feet long. How tall is the flagpole? So you ask yourself, okay, what are we comparing? We're comparing two things. We're comparing the height of two things. So the height of stuff over the length of their shadows. So length of shadow. Now you could have done this backwards. You could have done the shadow on the top and the height on the bottom. Guys, it doesn't matter. But I'm going to set mine up like this. And I like to write it out in words so that I stay consistent. So let's look at the first problem. A 6-foot tall fence post. Okay, well that's height. So 6 is going to go on the top. And on the bottom, we've got a shadow 2 feet long. Okay, so the shadow is 2 feet long. Okay. This is going to be equal to something, right? We're setting up a proportion. So at the same time of day, a flagpole casts a shadow 21 feet long. So does that go on the top or the bottom of my fraction? Well, shadow's on the bottom, so I've got to make sure that I put the 21 on the bottom. Now, I don't know the top. I'm going to call it x, right? That's what I'm looking for. How tall is the flagpole? If you can get this set up, you can get it right. I know you can. 2 times x is just 2x. 6 times 21 is, I think, 126. Let's check. 6 times 21 is 126. And we're going to divide both sides by 2 to find x. So x is equal to 63, right? Check it, divided by 2 is 63 feet. All right. Last but not least, here we go. Problem 5. An airline food service finds that a recent flight of 122 passengers ordered dinner as shown in the table. Based on this information, estimate how many lasagna dinners will be needed for a flight of 380 passengers. So we're looking at lasagna dinners, right? Okay. So what two things are being compared in this problem? Looks like we're comparing the number of passengers with the number of lasagna dinners people want. So we're going to say, how about passengers? And we're going to do over lasagnas. Again, it does not matter which one you do where. Okay? So the first one said that in a 122 passenger flight, right, that was in the problem, we had 25 people ordering lasagna. Again, that was in the table. We're supposed to figure out how many would order lasagna on a flight of 380 passengers. So where does that number go? Where does 380 go? We set it up to put that on the top, so we got to stay consistent. 380 has to go on the top. We don't know the bottom, we're going to call it x. Remember, as long as you can get this set up, you know how to solve, right? We're going to cross multiply. We got 122x is equal to 25 times 380, which is 9,500. Okay, last but not least, get rid of that 122, divide, and we've got x is equal to 77, I'm going to say 0.9. So how many lasagnas do I need, guys? Don't tell me 77.9 lasagnas. That makes no sense. Tell me 78 lasagnas. All right? Make sure especially when you're doing these word problems, make sure that they're making sense. Okay, our answer should be more than 25 because we have more people on the flight, that kind of stuff. Check your reasonableness. Okay? All right. Remember, when you're setting up proportions and word problems, stay consistent.